and welcome to another episode of FooBar. Today I want to show you a demo of an application I built for automating the dubbing of my YouTube videos. All of this process is using step functions, and I won't explore all the individual concepts or the code in this video, but I have all the concepts as separate videos in the playlist link in the description box, and the code is for sure available in GitHub, so you can go and check it out. But I want to show you the architecture and the architectural decisions that we made. So let's get started. So let's start from the beginning and let me show you what I built in action. I'm a backend developer, so there is no front end in here. So the idea here is to dub videos. I do them in English and then I can have them back in Spanish. So the first thing is to upload the video to S3 so the process can start. So we upload, in this case, some video to Kinesis, about Kinesis, into some bucket in S3. And then a state machine will start that will be picking up this event and doing the transcription of the video. We'll look at the details of each of these things later on, but basically this transcription will call the transcribe, AWS transcribe, and then do whatever it does and send me an email with an URL that I can click and I can open the transcription. Why is this? Because transcriptions usually are quite okay, but you need to tweak them in order to make sure that the results are awesome. So I will validate them, I will tweak them, and then I will upload the validated transcription again to S3 so we can do the translation. Now the translation happens. This is a very fast state machine, very simple. Again, I get an email and I can check that translation file. And here again, we do another validation because translations are okay. Sometimes there is some words that get translated that I like them in English and I want to fix them. So I fix that, upload the translation, the validated translation to S3, and now two state machines will start. The first one is one that will use generative AI to create titles, description, and tags for my video. And the second one is another state machine that will dub my video using Poly and some code that I have built. So now here, if I click in the link, I can see the description for my video, the title and the tags, so that's great. And then I can also wait for a little longer and I will have another email with the link to download the dub video. So with all this, I can wrap it together and I can upload it to YouTube. So this dubbing takes a little longer because it's going over the video using Poly and then dubbing the voice and then stitching that audio file that Poly generates into the original video, and boom, now the video is ready. So I get an email, I can download that video, I can open it, and we can see.
Bienvenidos a Serverless 101. Me llamo Eric Johnson y soy un developer advocate para AWS Serverless. Serverless 101 es una serie de videos que le ayudará a familiarizarse con los servicios de AWS que funcionan sin servidor.
Yes, this is my colleague Eric Johnson speaking Spanish. But this demo didn't start as a demo, it started as a real problem. If I have a YouTube channel, and I have two YouTube channels, I have one in English, this one that you're watching, and one in Spanish that I created a couple of years ago, and I noticed that I cannot do so many videos in Spanish because it's just hard to record everything twice. So I was thinking like how I can cater that audience with good quality content. I cannot clone myself, so that's something I can start there. I cannot hire another Marcia. So I wanted to create videos and make sure that the whole creation is automated. So when creating videos, there is a lot of steps involved. The most costly steps is the content creation itself, so making the scripts for each video, building the demos and things like that. But the good thing is that in that step, the language is not important. I can make the same video in Spanish or I can make the same video in English. We are good. But after the content is finalized, I need to record it. I need to put the lights, I need to put makeup, I need to set up the microphones, I need to get camera ready and then record, and let's not forget about editing. And there's so many aspects on video production. So if I want to redo the same content in multiple languages, then I need to iterate over the last parts of these video production things: recording, lights, microphones, putting makeup, editing, and so on and so forth for every language I want to create the content. So this is very time consuming, and I'm not a host, I'm not like an influencer or something like that, so I just want to get the content as fast as I can to you. I thought how I can automate this process with the tools that I have available. And this idea came to mind like last year when the whole Gen AI thing was coming to burst. And a lot of tools were appearing in the market that were doing quite crazy things with images and videos, and that gave me the idea. The solution you saw is more or less this. I want to upload a video to S3. I want some magic to happen, that this video get dubbed, and then I get an email to download it. In reality, I realized that the magic of the automation is good, but there still need to be a human involved, so I can validate the transcription and translation and things like that in the middle, so that they produce a result I'm more in control of and I feel more related to. So that's why you saw those validation steps in the middle. So now you know what I wanted to build and how I build it. Let's look at the architecture itself. This solution, as you saw, is all using step functions, and there were a lot of architectural decisions that I took when I was building that. So in a nutshell, this is the architecture of the application. There are 4 state machines that do very specific things, and they are connected through events like S3 buckets. Things get uploaded there. So the first question is, Marcia, why you are building 4 state machines and not a big one that does everything? And this question really got me thinking for a while, because this is a question I was like, why I should not build something big? Like could build something like this, a big state machine with a lot of smaller flows that you see in the screen. And this solution adds complexity in 2 ways. So that's why I didn't choose this one. And I want my solution to be as simple as possible. So the first way that this adds complexity is that we need to use the callback integration pattern. If you don't know this pattern, I have a whole video about it in the description box. You can go and check it. I have a demo and all of that. But this is what is happening in this scenario of the big state machine. Here you can see that I have 2 nested state machines together, the transcribe and the translate. There are 4, so I'm omitting part of it. But let's go step by step at what will happen here. So I will upload a file to S3, a new video, and that will trigger the state machine. That's good. Then that transcribe video will happen. And then when the transcription is done, we will store that transcription in S3. Great. Now I want a human to validate that transcription, and I will put an event in S3 to let know my human, either with an email or whatever, that there is a transcription ready. That will trigger a Lambda function that will store the task token maybe in a Dynamo table, and we are going to wait now for the human to validate the transcription. So now the state machine is paused, waiting for, in this case, Marcia to validate. So Marcia comes, upload the validated transcription into S3 again, and that will trigger another event bridge rule that will say, hey, trigger this Lambda function, fetches the task token, and then starts the execution again from the state machine. And now we go into translate step. So you can see here that this adds quite a lot of complexity, because now every time we want to extend this state machine, we need to add all these task token management all around. I want to take advantage of the whole event-driven architectures and the decoupling principle that is around it. So I will have these state machines that are doing its own thing, getting triggered when a new event comes in. And then if one day I want to add something to my workflow, I can just react to it and add a new state machine that reacts to that. And the cool thing is that happened because the generate assets, it's something I added later on in my demo, and it was very simple to add. If I wanted to add that new generate assets workflow, that generate using generative AI workflow, the one that does the description, the video title, and the task in the big state machine, I will need to modify the whole big state machine with its task token and the whole thing. There's a lot of code to be changed, and it makes extensibility harder. Now that we know more or less how the overall architecture looks, let's take a look at the different workflows that are involved and the most important things of each. The overall process is that a file gets uploaded, gets transcribed, then the transcript gets revised by a human, then it gets uploaded, that revision to S3, then it gets translated, then it gets revised by a human, it gets uploaded to S3, and then we dub the video and we generate all the assets. So let's see the first step, that is the transcription. So we get an event from S3, triggers a state machine, it calls Amazon Transcribe. We wait for the transcription with a waiting loop. So you might be saying why you don't use a callback task or why you don't use something else. And this is the simplest approach without having to create a lot of boilerplate around it. Maybe it's not the most efficient one, but here the transcriptions takes around 1 minute to be generated depending on the length of the video, so I'm fine. But if you have transcriptions that are very long, you might want to increase that wait time longer, or then you want to build the callback token piece for the transcription service. Then that gets stored in an S3 file, and then we will send an email. So that's very simple. So we can see then we have the translate step, and this step is very similar to the previous one. We have a rule: when a new validated transcription is uploaded to S3, we trigger the state machine, boom, we have the translated video. So the event, in this case, we'll call translate, and translate is a synchronous API when you have a small amount of text, and in our case we do. And then it again sends an email with the location of the translate file. And then we have the dubbing phase that looks exactly the same as the previous step. It does more or less the same thing. The dubbing step, what it does, it's called Poly. Poly will read out loud the translated text, and then it will send it to a Lambda function that will grab the audio and the original video and will stitch them together. And this works very well for shorter videos. So if you have longer videos, you might need to use a Fargate task. But in my case, the videos are short, so this works quite well. And when this is done, it's uploaded to S3, and then it's sent it by email. And then finally, we have the generate assets. That is exactly the same architecture. Events comes in, there is a new translation. It generates the assets, creates a title, descriptions, and tags using Bedrock, and then put it in S3 in a file for us. And in here, I have to update this slide, but we are using the optimized integration and not calling a Lambda function, but it's more or less the same thing. That's the architecture. If you want to see the code for the demo, it's available in GitHub. You can deploy it in your own AWS account. There are instructions, and there's a lot of information in the link I leave you in the description box. In the code, you will see a lot of the things that I've been talking about in this series, like error handling, intrinsic functions. You can see the optimized integration for Bedrocks, and way more things. So that was the video for me today. I hope you like it. Give a big thumbs up if you like this type of videos. If you want to learn more about integration patterns, you can find this video where I dive deep in all the integration patterns that are available in Step Functions. And if you want to learn more about Step Functions in general, check this playlist where there is like a whole course for free on Step Functions, so you can go from zero to hero in no time. And I see you in another episode of FooBar. Ciao, ciao.